Moving farther afield, we find ourselves staring at K2-18b, an extraordinary planet located 124 light-years away, capturing global attention due to confirmed water vapor detected in its atmosphere. K2-18b straddles the intriguing line between Earth and Neptune, an ocean world with thick atmospheres, immense oceans beneath its dense clouds. Beneath these clouds, who knows what incredible marine life might swim? Complex organisms, perhaps creatures illuminated by bioluminescence, thriving in deep oceans warmed by internal planetary heat. K2-18b challenges us to rethink our definition of habitable, showing that life may find endless ways to emerge and thrive. Seventh on our journey is Teegarden star B, orbiting a dim, quiet red dwarf star just 12.5 light-years away. This planet is fascinatingly Earth-like in size and orbit, placing it perfectly in its star's habitable zone. Scientists estimate surface temperatures ideal for liquid water, meaning oceans, lakes, and rivers could abound. Its host star is stable and ancient, billions of years older than our Sun, providing plenty of time for life not only to evolve, but perhaps even reach technological maturity. Could civilizations here be watching our solar system, wondering if Earth too is inhabited? Finally, we arrive at Gliese 667 cc, a tantalizing exoplanet orbiting one star in a triple star system 22 light-years away. Gliese 667 cc sits comfortably within its star's habitable zone, possibly hosting water-rich conditions on its rocky surface. Imagine the sky from this world, two bright companion stars casting spectacular double shadows across its landscapes. Life here could exist amid dramatically shifting daylight patterns, ecosystems uniquely adapted to thrive in an alien rhythm of day and night that's utterly unlike anything experienced on Earth. Each of these worlds expands our imagination, pushing us to rethink the boundaries of habitability, life, and intelligence itself. They represent our best chances, real, tangible, exciting opportunities to finally discover if we truly are alone or if the cosmos is brimming with countless other living worlds, each with their own astonishing stories, each waiting patiently for our discovery. Continuing deeper into our cosmic voyage, let's set our sights on GJ357d, another intriguing exoplanet orbiting a star just 31 light-years from Earth. This planet is captivatingly positioned at the edge of its star's habitable zone, colder than Earth perhaps, but still potentially warm enough for oceans beneath dense clouds or even beneath icy crusts heated from within. Imagine hidden oceans warmed by volcanic vents, ecosystems thriving in darkness, life evolving in ways we've never dreamed possible, microbial forms or even complex aquatic creatures dancing in eternal night beneath icy shells. Then there's Kepler 186f, 500 light-years away, but astonishingly Earth-sized, orbiting a red dwarf star within its star's habitable zone. This planet intrigues astronomers because of its potential stability and rocky composition. Picture vast alien landscapes, mountain ranges carved by weather and water, a world bathed in the gentle crimson glow of its red dwarf star. Could life here exist beneath strange, perpetual sunsets, adapting uniquely to low-energy stellar radiation? Kepler 186f reminds us of the endless adaptability and resilience that life might possess.
Imagine looking up at the night sky and realizing we're not alone. Out there, circling distant stars, are worlds brimming with possibilities. Worlds that aren't just barren rocks or fiery gas giants, but planets, real, tangible planets that could harbor life, perhaps even civilizations peering back toward us, wondering if they too are alone. Today, Cosmic Explorers, we're embarking on a journey to the top 8 exoplanets, worlds orbiting other stars that might just host alien life. First, let's zoom in on Proxima Centauri b, our closest cosmic neighbor, orbiting within the habitable zone of Proxima Centauri, a mere 4.24 light-years away. Picture this, a rocky planet roughly Earth's size, close enough that its host star warms it to just the right temperatures where liquid water could flow across its surface. Yes, it's tidally locked, meaning one side is eternally bathed in sunlight while the other remains forever dark. But at the border between these extremes, in the twilight zone, conditions could be just right. Oceans, lakes, rivers, perhaps even ecosystems thriving in permanent twilight. Imagine alien forests under crimson skies, just a short cosmic hop from our own backyard. Next stop, TRAPPIST-1e, part of the incredible TRAPPIST-1 system, a mere 40 light-years away, packed tightly with 7 Earth-sized worlds orbiting a tiny red dwarf star. TRAPPIST-1e stands out as the perfect candidate, a rocky planet nestled right in the star's habitable sweet spot. It could host sprawling oceans or thick, life-sustaining atmospheres. Imagine a sky filled with nearby planets, visible as large as moons, painting spectacular views. Life here could be abundant, thriving under a soft, perpetual sunset, waiting patiently for humanity to take a closer look. Third on our cosmic itinerary is Kepler 452b, nicknamed Earth's cousin. Located 1,400 light-years away, it's eerily similar to our own world, but larger, a super-Earth orbiting a star almost identical to our own Sun. Its orbit lasts just slightly longer than Earth's own, placing it squarely in the ideal zone for water, air, and perhaps life itself. With its stable orbit and Sun-like star, Kepler 452b might host continents, oceans, and vibrant life forms. Imagine evolutionary paths similar to our own, oceans brimming with alien sea creatures, lands populated with life adapted to conditions we would find strikingly familiar. But what about planets orbiting stars different from our own? Enter LHS 1140b, a massive rocky super-Earth orbiting within the habitable zone of its quiet, stable red dwarf star just 40 light-years away. Scientists are excited about this planet because it's incredibly dense, likely holding on to its atmosphere for billions of years. That's plenty of time for life to arise, evolve, and possibly flourish. Its thick atmosphere could shield life from stellar radiation, allowing stable, long-term conditions for complex organisms, perhaps even intelligent life, gazing out into the cosmos with their own questions about existence. Our fifth remarkable world, Ross 128b, orbits a calm, steady red dwarf star just 11 light-years away. That's practically next door on cosmic scales. Ross 128b is likely rocky, temperate, and stable, spared from violent stellar flares that plague many other planets around red dwarfs. Conditions here might be comfortably mild, allowing oceans and possibly vast ecosystems. Imagine gentle winds blowing through alien fields, calm seas reflecting alien moons, a paradise not too different from our own earthly dreams.
And what about TOI 700d, a recently discovered exoplanet orbiting a quiet, small red dwarf star just 100 light-years away? TOI 700d excites astronomers because it's perfectly Earth-sized and receives just enough warmth from its star to support liquid water on its surface. Computer simulations suggest this planet could host stable atmospheres and possibly extensive oceans. Imagine vast seas reflecting a softly glowing red sun, coastal regions teeming with organisms, forests thriving under alien skies. This planet could hold ecosystems quietly mirroring Earth's biodiversity in astonishing and unexpected ways. Next, let's marvel at HD 40307g, located approximately 42 light-years away. A super-Earth that comfortably sits in its star's habitable zone. With gravity slightly stronger than Earth's, life here would need to evolve robustly. Organisms might develop sturdy structures, dense bones, or powerful limbs. Vast oceans and continents could support dynamic weather patterns, allowing diverse habitats, rainforests, deserts, and temperate zones, all thriving under conditions just slightly more intense than Earth's. It's an exciting prospect, a world of resilient, vibrant life capable of adapting to heavier gravity with astonishing creativity. Gliese 832c, another cosmic gem at just 16 light-years away, is considered one of the best candidates for habitability, orbiting a quiet red dwarf star. Slightly larger than Earth, this planet may possess Earth-like conditions, oceans, and perhaps even atmospheres enriched with oxygen produced by photosynthetic life. Imagine forests of alien vegetation absorbing dim starlight efficiently, plants colored red or even black, photosynthesizing in ways we've yet to conceive. It's a vision that compels us to redefine what life can look like, challenging our assumptions about biology itself. We can't overlook Wolf 1061c, just 14 light-years away and within easy observational reach. Slightly larger than Earth, this rocky planet resides comfortably within its star's habitable zone. Surface temperatures may permit liquid oceans, atmospheres rich enough to sustain weather patterns, perhaps even moderate climates ideal for complex life. Imagine civilizations potentially arising beneath gently dimmed skies, their cultures shaped by their star's soft glow, perhaps even dreaming, as we do, about other worlds orbiting distant stars. Our exploration leads us now to Tau Ceti e, located just 12 light-years away, orbiting one of the nearest Sun-like stars. Slightly more massive than Earth, Tau Ceti e rests within its star's habitable zone, potentially harboring liquid oceans, stable atmospheres, and diverse surface ecosystems. Imagine continents teeming with life, oceans filled with alien marine creatures adapted to slightly stronger gravity, skies illuminated by an almost familiar sun. It's a tantalizing thought, life arising under similar but intriguingly different conditions. Lastly, let's journey to the mysterious planet Teegarden star C, a neighboring planet orbiting the same tiny red dwarf as Teegarden star B. Slightly cooler and further from its star, it may host colder climates, perhaps ice-covered continents beneath which oceans remain liquid thanks to internal heating. Life here could persist in hidden pockets beneath ice sheets, much like Earth's deep Antarctic lakes. Imagine complex ecosystems developing in darkness, thriving in subterranean oceans, never needing sunlight, sustained instead by planetary warmth and chemical reactions. Each of these incredible exoplanets reveals to us a thrilling truth. The cosmos may be bursting with life, thriving in forms we've barely begun to imagine. From the nearest stars to distant stellar neighborhoods, worlds await, diverse, astonishing, and perhaps teeming with beings peering toward our sun with the same curious wonder we feel when we gaze up into the infinite heavens.